Alright, 5.6, find rational zeros. So the beauty is, you already know how to do half of it. Because you know how to do synthetic division. Yeah. Okay? Also, tomorrow, I'll give you guys the extra credit worksheets, and I'll try to grade the homework from that section sometime tomorrow at the latest over the weekend. So that way you'll know if you did them correctly before you do the whole extra credit worksheet wrong. Okay? Okay. You can't hear it here, but you can definitely hear it there. And with subtitles, it's really funny. Earlier, the subtitles didn't hear what I said, and it wrote blood in a pencil. What? Yeah, and that was not even close to what I said, so... Alright, the rational zero theorem. Okay, this is the one theorem that we get in this section. I think it's the only one. Yes, it is. Alright, so this says if f of x is equal to a sub n x to the n plus plus a sub 1 x plus a sub 0 has integer coefficients. Then every rational zero of f has the following form. A sub n x to the n plus a sub 1 x plus a sub 0. Alright, has the form P over Q is equal to the factors of the constant term A, or a sub 0, I should say, over the factors of the leading coefficient Probably forgot what day it is probably the real problem. Okay, so the nice thing is, once we get into this, the book works you up to it. First, it asks you to find all possible ones, and then it asks you to find which ones actually are zeros. So it works you in nice and slow. Where? A sub n? Yes. Because there is a problem that you will do for homework that has 16 possible zeros. Yeah. No, usually there's like 3 or 4 there, actually. Because this is a way to find them without actually knowing what they are. But the beauty is that means you get your calculator for this part. black. So I'm going to write the problem down. Does it throw you off when I change a color like every step? Well, I don't want to get, like, super ahead, and then, like, if he's joining, that he's going to miss it. So, okay. All right. Number 4. All right, so this is list all possible rational zeros of the function using the rational zeros theorem. Okay. It sounds scary. It's not actually. Not this part. Yes. All right, g of x is equal to x cubed minus 4x squared plus x minus 10. All right, so based on the rational zeros theorem, we're going to do the factors of the constant term a sub 0. So our constant term is 10. Okay, and then over the factors of the leading coefficient a sub n. Our biggest x value is right here. It has a leading coefficient of 1. So it's just a constant term. The constant term that goes with the biggest x power. So again, it has to be in standard form, or at a minimum, you have to make sure that you're using the biggest x power if you're not going to rewrite it in standard form. Most of the time, they will give it to you already in standard form, but just don't, like, be tricked by it. Okay, and if it's missing terms, that doesn't matter. Okay, for these ones. Correct. Well, yes, when you do the synthetic division, but it's not relevant for this first part. Okay, so we have 10 over 1. Okay, now we have to account for the positive and negative factors. Okay, so I need all factors of 10. So how do I prime factor the number 10? Okay, 5 and 2, okay, and then also I have 1 and 10 that's going to be counted in. So it's plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Yes. Yes, they have to be in numerical order. Okay, now on the bottom, 1 is easy, it's just plus or minus 1. Okay, now, I'm not done. Now I actually have to write out all possible ones. Okay, so I'm going to switch colors again. Okay, so all possible ones, can y'all see the orange? Okay. Plus or minus 1. Okay, so 1 over 1. Plus or minus 2, because it's over 1. Plus or minus 5, because it's over 1. And then plus or minus 10, because it's over 1. So in this case, there are 8 possible zeros total. Because you have the plus and minus. Okay. Because at some point, this isn't going to be a 1 down here. So if there was also a 2 down here, it would have been also plus or minus 1 over 2. Now, if you have something, so if it was a 2 down here, this 2 over 2 is equal to 1. 1 is already written. We don't write it twice. Okay? You only write it once. Okay? Then it would have been 5 over 2 and 10 over 2, which was 5. 5 was already written, so we wouldn't have written it down. Okay? At that point, they don't have to be in numerical order, but you need to go in order across. Okay? Because when I'm checking it, I'm looking for them, and if you have them all in a weird order, it's very, very hard to grade. Okay? So when we do it, you'll see what I mean by going in order. Okay? This was an easy one. That was all. That's all you have to do for this part. Yes. There's a lot more. Yes. Yeah, so this is all possible. So all possible will get written out here. Yes, so like 1 over 1, 2 over 1, 5 over 1, 10 over 1. And then let's just say this number had been 2 instead of 1. Then I would have also written then 1 over 2. 2 over 2 is 1, so I wouldn't have rewritten it. 5 over 2, and then 10 over 2 is 5, which I already had 5, so I wouldn't have rewritten it. And then you're... Correct. The other thing is, then what you would do, okay, we're not at this step yet, but then what you would do is you would plug the function in your calculator, and then I'm going to teach you how to find what the zeros approximately are. Then based on that, you're going to pick one of these that's close to it and see if it truly is one of them. Yes. But there probably is only 3 of them that actually are true zeros. It'll make more sense once you see it. Because right now I'm just verbalizing it to you because I want to get this step down first. Yeah, so like 5 might not work, but 2 might. But negative 5 might work. But your calculator will give you a hint as to which ones will work. And that being, the reason is, this is not something we could just factor off the top of our head. Okay, so if we need to solve, that's not something we can factor. So that's why we have to do this. Alright, number 6. H of x is equal to 2x cubed plus x squared minus x minus 18. Sometimes it works out nice, sometimes it doesn't. She was talking about a hypothetical option. Alright, so I want to list out the factors, okay? So again, I'm going back to this form, okay? So the factors of the constant term is going to be 18 over the factors of the leading coefficient, which is going to be 2. You can, but you're going to always write positive or negative for all the factors, so it really doesn't matter. I usually just don't because I'm tired of writing positive and negative by the time I do all of this. So let's start with the bottom because it's easy. 2 factors into 1 and 2, so plus or minus 1, plus or minus 2. Okay, now I need all the factors of 18. Just 2 is just 1 times 2. If it was 4, then that would be 1, 2, and 4. Okay, it's just whatever you're multiplying together. So you have to think about, like, okay, what pairs of things work together. So, like, for 18, okay, I know that 1 and 18 work, but I'm not going to write the 18 yet because I need to write them in number order. Like, 1 times 18, yeah, 2 times 9, 3 times 6, okay, things like that. So I'm going to write plus or minus 1. Okay, then plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. Okay, now I need to go through and write all possible ones. Okay, you're going to need more space in this little tiny bit here, so I would start a new line. Okay, so I'm going to have all of these numbers written over 1, so I'm going to go ahead and just write down all those numbers down here. Okay, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. Okay, now, so that takes care of all these numbers written over 1. Now I need to do all of them written over 2. If I have one that repeats, I don't write it. No, so that's why, yeah, so I want you to do, in order, all the numbers across the top divided by the first number. Then all the numbers across the top divided by the second number, in order. Okay, don't go back and rewrite them in number order, that just gets confusing. Okay, so 1 over 2. Okay, and all these are plus or minus. I'm just not going to say it because I'm writing fractions. Okay, 2 over 2 is 1. 1 is already written, so we don't write it. Okay, 3 over 2. Okay, 6 over 2 is 3. 3 is already written, so I don't write it. 9 over 2. And then 18 over 2 is 9, so I don't write it again. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 18 possible zeros in this one. Because otherwise you won't know how to approximate the ones that will be zeros on your calculator. Huh? Because plus or minus for each one. I think I counted right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. All right. Nope, that's all you have to do. I'm just saying how many possible ones there are so you get used to seeing it. No. Yes, you have to get 0 when you go through and do synthetic. But, I mean, I could be really mean and I could make you do 18 sets of synthetic division to figure out which ones are actually zeros. But I'm not that mean. So, you'll get to use your calculator to determine which ones you think might be zeros, and then you'll check by synthetic to verify that they are. No. Well, not in this class. Theoretically, yes. Usually you'll always have one real one. But like in pre-cal, we have a lot of non-real ones. So it looks like we should have some, but most of them end up not being real. Like they're imaginary numbers. So you won't actually find those ones, not this way. Alright. Number 8. F of x is equal to 3x to the 4th plus 5x cubed minus 3x plus 42. Alright, so I'm going to let you guys tell me how to set this one up. That doesn't matter for this. That will matter when you write your synthetic division. Okay, so for this step, that doesn't matter. But for the synthetic division in the next step, it would matter. Yes. Yes. Okay, so 42 over 3, first of all. Okay, you always... Huh? I mean, it doesn't matter. I don't care either way. Okay, hold on. Okay, so on the bottom, 3 can factor into 1 and 3. Okay, if you want to start with the top or start with the bottom, I don't care. 3's easy, so I'm just writing those two to get them out of the way. Okay, now then at 42, you got to find all possible ones. Okay, so obviously 42 is not a number we think of a whole lot. So the way, like Hope was just saying, she was like, okay, 3, trying to figure out what the other number that's going to go with it is. Okay, to make sure that it actually is. The factor tree? Well, you're not exactly doing a factor tree. You're multiplying. It's like what times what gives you 42. So like 1 and 42. And then 2 and 21. So yeah, so if you want to, I mean, I don't know how many there are going to be in here. So I mean, if you want to, you could do like 1, and then out here you could do 42. And then you could do your 2 and 21. And then what'd y'all say 3 is? So the only issue is you might not have a lot of space, so like I didn't really have enough space, so I kind of like crammed them all in there. Okay, and like theoretically, there could be more numbers on the bottom. Okay, you could have a bigger number. It's not always going to be a small number in front. Now, usually they're not super mean. The biggest number that I see in front is a 6. No, an 8. The biggest number I see in front is an 8. 1, 2, 4, and 8. Well, technically, it's only 2 times. So, like, if it was, like, let's just say the number was 4 on the bottom. You would only write 1, 2, 4, not 1, 2, 2, 4. Because that would just be everything repeated, so there's no reason to write it twice. Alright, so now I need all possible zeros. Okay, so it's going to be all these numbers over 1. Okay, and then we'll go through and do all the ones over 3. One over 3. So we did all the numbers over 1, so now we're doing all of them over 3. If anything repeats, okay, so like 3 over 3 is going to be 1. That's going to be a repeated 1. We don't write it. Okay, so hold on. So we had the 1. So hold on. So we had 1/3. Then we had 2/3. Okay, we said 3 over 3 is 1, so we don't need to write it because it's already there. Then we said 6 over 3 is 2. We don't need to write it because it's already here. So now we're at 7 over 3. Okay, and then now somebody else can keep going. Okay, because 21 over 3 ends up being 7, and 42 over 3 is 14, so we don't have to worry about those ones. Yes, because there's plus or minus. So this is like, yeah, everything is plus or minus. I got it. Down here? So whatever number this is, you're doing the same thing you're doing up here, where you're multiplying everything. So this one is just 3 and 1. But like then if it was 4, it would be 1, 2, and 4, because you only write the 2's once. If it was like 10, it would be 1, 2, 5, 10. So you could end up with a whole lot more options down here. But a lot of times when that happens, what ends up happening is a lot of things are going to cancel out as you go. So you just go across. So obviously each of these is just over 1, so I just repeated those down here. Oh, so the formula, so the factors of the constant term go on top, so that was the 42 for our problem because it was just 42 with no x's. And then the other one is the leading coefficient, so the one with the biggest power of x. All right, I'm going to have you guys try one. No. I want you guys to try this one, and then we'll go over it. Yes. All right, number 10. H of x is equal to 6x cubed minus 3x squared plus 12. All right, so work this one on your paper. Yes, and then it's going to end up being undefined, so. There shouldn't be any that they give you that don't have a constant term. No. Okay, and remember, if a fraction shows up twice, you don't write it twice either. Okay, it's not just the whole numbers that you don't write twice. You should have 12 written to 24 possible when you're done. So 12 will be written, 12 different numbers, but then they're all plus or minus. Alright, I'm going to give another minute. Like the number 3 or 3 possibilities? Yeah, you can have a ton of possibilities. This one has 4 possibilities on the bottom. Yeah, so that would reduce down into like 1/2. So if you've already written 1/2, you wouldn't write it again. Alright, y'all ready to go over them? Alright, I'm not going to have you guys read off to me what they are, so I'm just going to put it up there. Okay, so for your numbers, you should have had 1, 2, 3, 4, 6, and 12 on top, 1, 2, 3, 6 on the bottom. Okay, so then 1, 2, 3, 4, 6, 12, okay, as the numbers, and then it goes from there. So 2 over 1 is already taken care of. 2 over 2 is just 1, so that one was gone. Or, well, I guess I should have started with 1. So it was 1 over 2, 1 over 3, 1 over 6, okay, and then 2 over 3, 2 over 6 was 1/3, which was already there. 3 over 2, the other ones were already there. 4 over 3, other one's already there. And then 6 over all those numbers and 12 over all those numbers is already there. Yes. Hold on. They need to be in this order. Like, you should work your way across like I did. So what you should do is do all of these ones first, all the ones that are over 1 first. Okay, and then you start back here and work your way across. I mean, as long as they're there, I can't really mark it wrong. but it makes my life a lot easier, and it'll be easier for me to find your mistake rather than just counting them and being like, oh, you don't have 12. Alright, so there's like 10 minutes left in class, I think. So what I'm going to do is I'm going to go ahead and give you your 2 problems out of this stuff that you would do for homework, and then that way tomorrow, when you're experienced in how to do these, we can move on to the next step, which is actually doing it on our calculator and finding them. No, but I would prefer that you work on them now so that you've gotten a little more practice with them. Okay, number 3 and 9. Okay, I'm just going to tell you, number 9 has 16 possibilities. But in reality, that's actually 32 total possibilities. This is how many different numbers you should have written.